Welcome. Today we're diving into the fascinating world of physical quantities. Have you ever wondered how scientists measure everything from the length of a table to the brightness of a star? It all comes down to two main families of quantities, fundamental and derived. Understanding these is like learning the alphabet before you start reading and writing. By the end of this video, you'll see how simple building blocks can help us describe the most complex phenomena in our universe. Let's get started by exploring what these two families are all about. First up, fundamental quantities. These are the independent basic quantities in physics. They cannot be broken down or expressed in terms of any other physical quantity. Think of them as the primary colors in painting. Everything else is made by mixing them, but they stand alone. There are exactly 7 of these, and each one forms the foundation for all other measurements. Let's take a closer look at each one and see why they're so important. First fundamental quantity is length, measured in meters. Whether you're measuring the height of a building or the distance between two cities, length is always at the core. The meter, symbolized as m, is the standard unit. This simple measurement is essential for everything from construction to navigation, and it forms the basis for many other derived quantities. Next, we have mass, measured in kilograms. Mass tells us how much matter is in an object. Whether you're weighing a bag of apples or calculating the mass of a planet, the kilogram, symbolized as kg, is your go-to unit. Mass is a cornerstone in physics, affecting everything from gravity to momentum. Time is another fundamental quantity measured in seconds. From the ticking of a clock to the age of the universe, time is everywhere. The second, symbolized as c, is the universal unit for measuring time. It's crucial for understanding motion, speed, and countless other physical phenomena. Temperature is measured in Kelvin, symbolized as K. It tells us how hot or cold something is, from the freezing point of water to the heat of the sun. The Kelvin scale is used in science because it starts at absolute zero, the coldest possible temperature. Understanding temperature is key in chemistry, physics, and everyday life. Electric current is measured in amperes, or A. This fundamental quantity tells us how much electric charge flows through a circuit per second. From powering your phone to lighting up cities, electric current is at the heart of modern technology. The ampere is the standard unit used worldwide. Amount of substance is measured in moles, symbolized as mol. This quantity is especially important in chemistry, where it helps scientists count atoms and molecules. 1 mole contains exactly 6.022 x 1023 particles, making it a powerful tool for understanding chemical reactions and formulas. Luminous intensity is measured in candelas, or seed. This fundamental quantity tells us how bright a light source is. Whether you're comparing light bulbs or studying stars, the candela is the unit that quantifies brightness. It's essential for fields like lighting design and astronomy. Now that we've covered the 7 fundamental quantities, let's move on to derived quantities. These are created by combining 2 or more fundamental quantities through multiplication or division. Think of them as words and sentences formed from the alphabet of fundamentals. Derived quantities help us describe more complex properties like area, volume, and speed. Area is a classic example of a derived quantity. It's calculated by multiplying length by breadth, giving us square meters m2. Whether you're measuring the size of a room or a football field, area helps you understand how much space is covered. It's a simple combination of fundamentals that's used in countless real-world applications. Volume takes it a step further by multiplying length, breadth, and height. The result is cubic meters m3, which tells us how much space an object occupies. From water in a tank to air in a room, volume is a vital measurement in science, engineering, and daily life. Speed is another derived quantity, calculated by dividing distance by time. Its unit is meters per second, ms. Whether you're timing a race or calculating how fast a car is moving, speed combines 2 fundamental quantities to give you a deeper understanding of motion. Electric charge is found by multiplying electric current by time, resulting in the unit coulomb c. This derived quantity is key in understanding how electricity flows and is stored. It's used in everything from batteries to electronic circuits, making it a fundamental concept in technology. Density is calculated by dividing mass by volume, giving us kilograms per cubic meter, kg/m3. This derived quantity helps us understand how tightly matter is packed together, whether it's a block of metal or a cloud in the sky. Density is crucial in fields like material science and meteorology. Every physical quantity has 2 parts, a numerical value and a unit. For example, in 10 kilograms, 10 is the value and kilogram is the unit. This combination is what makes measurements meaningful and universally understandable. Without both, a measurement would be incomplete and confusing. Understanding the difference between fundamental and derived quantities is crucial. It's like knowing your alphabet before you can form words and sentences. Fundamental quantities are the building blocks, while derived quantities are the complex ideas you create from them. This knowledge is the foundation of all scientific measurement and discovery. So the next time you calculate area, speed, or any other derived quantity, remember, you're combining the power of fundamental units. That's the beauty of measurement, simple building blocks coming together to create a complex yet understandable picture of our world. Measurement is more than numbers, it's the language of science.